Hello, this is a session on understanding EtherChannel load balancing on Catalyst 6500 switches. Although this is a very load balancing specific session, to give you a quick introduction on EtherChannel. So EtherChannel allows you to bundle multiple physical Ethernet links to combine into one logical channel. This allows load sharing of traffic among the links in the channel and increases bandwidth. Also provides redundancy in the event that one or more of the links in the channel fail. So you can split links across multiple modules, for example, to protect against card failures, as well as interface, SFP, fiber, copper failures, etc. It's a typical topology showing 4 times 100 meg links bundled into a single ether channel between a core switch and an access switch. So how does ether channel load balancing work? The key point to understand is that one traffic flow will only ever use one member link of the ether channel. So a flow can still be restricted to a lower speed than the ether channel itself. So in the above example where you've got 4 times 100 meg links, any one particular traffic flow from source destination, one TCP flow, will only ever use up to 100 meg of that bandwidth. Determining which member of a channel's specific traffic flows down can be invaluable for problem determination and also planning for high volume flows such as backups. And the algorithm is deterministic, so if you use the same addresses and the same session information, you have TCP, UDP port information, you will always hash to the same port in the channel, and this method prevents out of order packet delivery, which is probably not an issue if you've got 2 switches right next to each other, but if you're using long distance fiber links, for example, that could be hundreds of kilometers long, that could follow different routes. That would introduce delay between the packets, which is not good. So the EtherChannel load balancing algorithm, basically you can base the load balance policy or the frame distribution policy on the following: MAC address, which is layer 2, IP address, layer 3, a port number, so UDP TCP port number, which is layer 4, and it can be source, destination, or source and destination. To configure load balancing, it's very simple. It's a global config only, so it can't be different on a per channel basis. And there's a single command. It's if you issue the port channel load balance and then the load balancing method of choice as listed here. That's it. Effectively, it's a global command. And then to verify it, you can issue the show ether channel load balance command to check the policy is taken. So here's an example showing load balancing being configured using source destination IP address, and then verifying. You can see here that source destination IP enhanced is used, which the enhanced is just specific depending on which policy feature card you've got configured in a present in a 6500. So to determine which member will carry specific traffic, it's a really practical use, particularly for some users, for some troubleshooting issues and also planning for high volume traffic. So for example, I had an issue a few weeks ago where some users at a site were having real trouble accessing an IP address, and other users on the same site using the same layer 3 path were working perfectly fine. And ultimately we found there was a member of an ether channel that was highly erroring, and traffic that was flowing over that interface only was affected. So now you're aware of the frame distribution policy configured from the previous section. You can query the switch processor based on that. On a 6500 you've got a root processor and a switch processor. Generally the command line is based on the root processor, so you need to remote log into the switch in order to query the switch processor. That command is just remote login switch, hit carriage return. Then once you're on the switch processor, and you'll see by the SP tag on the end of the prompt that you're on the switch processor, just issued a test ether channel load balance interface port channel and port channel number, which in our case would be 1, and then based on what your load balancing mechanism is set to, the IP address, source IP address, destination IP address. That could be source MAC address, destination MAC address, for example, or also source IP address and port, destination IP address and port. Hit command, hit return on that command, and it will tell you which member of the port channel that traffic will flow over. And in this instance we can see that gig 6/1 of the port channel is being used for that particular traffic, and it'll always be gig 6/1. From that then you can focus in on that interface and see if there are errors, unidirectional link, error in frames, that kind of thing.